Let's get right to it. What do you need to learn to become a real-world machine learning engineer? What languages and tools you're going to use every day? Let's find out. Number 1, SQL. Why? Because all machine learning models are fed data. The cleaner your data, the more accurate your model. Most machine learning models right now are based on data from relational data stores. All relational data stores and just about everything else speak SQL. You'll need to learn how to write queries to extract that data from modeling. Real-world data is dirty, and working with it sucks. If you don't have SQL skills, you're doomed. Number 2 is Python. Why? Python has become the gold standard for machine learning in the real world. It's the language you're going to use every day for just about everything, once your data is amalgamated in a data store. Number 3, the libraries. Why and what are they? A library is code that's pre-bundled. You simply need to import the library into your environment to gain all the functionality of that library. Libraries are as important as Python. If you don't know the libraries, you won't get a job. There are libraries for just about every facet of machine learning. You don't have to know the libraries, but they're a core group you're going to use every day. Those you must know are Pandas, scikit-learn, XGBoost, Matplotlib, and a few more. Number 4, the big one, data cleansing. Why and what is it? Data cleansing are all the tasks associated with preparing your data for modeling. Remember what I said earlier? The data is dirty. Extracting your data is the first part when you're working with data. The next part, the fun part, is data cleansing. It's what you're going to spend most of your time doing, I promise. Number 5, applied statistics. Why? The process of working with the dataset and developing a predictive model is also a task in statistics. Although statistics is a large field with many esoteric theories and findings, the nuts and bolts tools and notations taken from the field are required for machine learning are quite easy to learn. You're going to use libraries we spoke about earlier, mostly scikit-learn, to apply statistical techniques to your data. That part of data cleansing is knowing what statistical techniques to apply to your data and when, and of course why to do it. Notice I said the word applied. Applied means applying statistical techniques that are already written in code. You don't do any of the statistical calculations yourself. These are already written inside libraries. Number 6 is modeling. Why? A model is simply a computer algorithm or a group of them that look at patterns in your data. When a model finds patterns, they return an output. We call them models. There are different types of models for different problems. For example, the most common type of task in the real world is classification. A group of ensemble models excel at this. They are called gradient boosters. When you're working with structured data and your problem is a classification task, you'll want to use gradient boosters. There are 2 core types of models. They're called traditional models and deep learning models, and each has their own use case. Number 7, tuning. What is it? Tuning a model means making tweaks to the parameters called hyperparameters. The default model might not provide you with the best results. You'll need to know what hyperparameters to tune for a given model. Yes, different models will have different hyperparameters. However, since you really won't be using that many models in the real world, learning them isn't that difficult, and oftentimes the default model is well tuned. Number 8, production. Why? The only reason you're going through all this work is so that you can produce a model that's going to make predictions on fresh data. Fresh data is data the model has never seen before. This is the end goal for all models. Now, how a model is put in production is going to depend on the type of model. If the model is a real-time model, a front end is going to need to be created so it can be consumed. If the model is batch, then you'll need to create a process to output the files to a location where those results can be consumed. Number 9, niches. Why? There are many different subfields you can move into once you have a foundation in machine learning. For example, there are people who only study NLP or natural language processing. There are others who only study computer vision, yet there are still others who only study reinforcement learning. I focus solely on gradient boosters and ensemble models because they're the gold standard for regression and classification, the most seen problems in the real world. Thanks for watching. Don't forget to like and subscribe, and have a great day.